Hi, everyone. As Geraldine mentioned, I'm one of the software developers on the pipeline platform that we run at the Broad. I'm pleased to speak to you today about pipelining platforms. A couple questions. Has anyone used a pipeline solution in the past? Maybe like SnakeMake? What have you used? Nextflow, yeah, that's popular. Do you like it?
Yeah, it works pretty well.
Yeah. Is it anyone else used SnakeMake? Yep. Any others? Okay. One more? Yeah. SnakeMake too. Cool. All right. Well, today we're going to talk about WDL. That's one domain-specific language we've developed at the Broad, and the engine that runs it is called Cromwell. And there's a nice portal to organize everything around it and run the execution for you. That's called Terra. So the goal we're going for here is to automate repetitive tasks. There's some nice parts about that if you create static workflows, that increases the auditability and the reproducibility. But this is very repetitive, and it would increase the chance of human error if you were to run these things yourself. So what we're doing today is we're going to create a script that defines a workflow, and then you give it to Cromwell or Terra, and it executes it for you and manages any sort of like system or infrastructure failures on your behalf. So I'm going to give you, I think XKCD summarizes the situation. There are a lot of workflow solutions out there. We looked at them all and found them wanting, but I'll give you just a second to appreciate this. So we did exactly this. We looked at the 14 out there and said, well, this doesn't cover us. So we wrote our own. It became WDL. And today we have WDL, and it lives alongside Nextflow and SnakeMake and all the others out there. And that's just the way it is, unfortunately. So this is kind of a high-level view of WDL. We're going to go into this in more detail later in the workshop. But the takeaway here is that it's meant to be a human-readable scripting language. It has some basic type support. It has a fairly straightforward syntax of calling tasks, and tasks can depend on the outputs of other tasks. And then the tasks themselves wrap like a Docker container to give it a shell script command, and then inputs, and ultimately you define what files or what values you'd like to output from the tasks. So I mentioned Docker containers in the last slide. Docker containers are a nice way of packaging a shell script on top of an operating system. So it's kind of defining a computer in a box. There's a Docker kernel, but ultimately within a container that you choose Linux operating system, all your dependencies that you need. We offer GATK, for example. There are other ones out there that are very popular. But it's, like I said, it's kind of like a computer in a box. You declare everything, and then ultimately, as we saw, you declare a shell script to run on that computer. It's a nice way to make things reproducible. It's a nice way to be portable. These things are stored in places like Docker Hub. On Docker Hub, you can share. You can make things private. There's a security layer on top of them. And so you have your containers and you have your WDL, and now you need to run that somehow. This is where I come in. I'm the tech lead on this Cromwell execution engine. We currently support WDL and Common Workflow Language. Does anyone use CWL here? Okay. Your institute? Yes. Okay, so the idea is that we can take these workflows, break them down, and turn them into individual jobs. And those jobs can be run locally on your machine, on your laptop. They can be run on a local cluster that you might have. But ideally, you'd like to execute them somewhere on the cloud, and we'll get into some reasons why that's the best approach. So kind of the way things were, if you had an on-premise cluster or maybe your computer itself, you have essentially many number of these data repositories. They're sort of siloed around. Each place implements their own security model on top of this. But one of the biggest things is cost. So this requires a large capital investment. You need to build a cluster. You need to maintain huge machines. And it's can be inefficient if you're not taking full advantage of that investment you've made. So the cloud goes a long way towards solving these problems. They have a very robust security layer. They have trivial data sharing. So if you want to share it with someone else, it's a matter of setting a new pointer with new access controls, again, managed by the security layer. But the biggest benefit, I think, is in the cost. So it's basically zero upfront cost. There's no capital investment required. And the compute infrastructure that you're using is elastic. So you're only using what you're using, and you're not paying for anything besides what you're currently spinning up in the cloud and utilizing. So it's much more efficient in terms of getting the most bang for your buck in terms of infrastructure. This is some of our data from the Broad. And I think the takeaway here is that it's very spiky. Every so often there'll be a conference or something where people are trying to run their workflows and get them done. And instead of waiting in a queue, we go to Google and ask for more servers, and we can handle, as you can see, highly variable amounts of work every single day. So, and the other thing to note is that in these troughs, we're not spending any money. So literally the cloud on our behalf is just idle. All right, so let's look at the development cycle with WDL. So Cromwell, as I said, supports many backends. When you're writing your script, you're probably going to want to either locally on your laptop or on a local cluster. So during this time, you'll be utilizing the local backend. And then when it's more stable or you're happy with it, you can run it in a production environment, which consists of the cloud. You can also do things like have a running Cromwell server that has both a local and a cloud backend, so running sort of a hybrid environment. So it's very flexible in terms of how you use it. It's also flexible in how you interact with it. So you can run command line from the command line, GATK, interacting with the cloud. You can run your own Cromwell, which is kind of a sysadmin balance there. There's a little bit of overhead in terms of configuration and maintenance, operations concerns. But you can run Cromwell. It's open source. You can download it today and run it. You can also use a package product that we offer called Terra. So Terra is and there's kind of a lot of data here, but it's a cloud-based platform. It's free to access. If you choose to use it, you get charged by Google for the compute and the storage that you're using. And it's a nice way to access all of these different tools that we offer. So we offer public data repositories. We have public workflows. The execution engine, Cromwell, will run on your behalf. So there's no operations overhead with respect to that. You can run interactive analysis using Jupyter notebooks and some other things we'll talk about. And there's a security model that's basically using the cloud on your behalf also. We do run on Google Cloud, but that's not to say that, again, you can take Cromwell and run it however you choose. So I think it's a little funny that it says makes running easy, and then it shows a very busy slide. But I think the takeaway here is that you as a researcher focus on two things. Basically, the script itself, what you want to run. You nominally have to pay some attention to the container. Basically, if you're developing your own containers, if you're using public ones, you don't have to worry about this stuff. but you worry about the script, and then you're interacting with the data model. We have stored data all over the place, public data sets, your own data you can upload to the cloud. And on your behalf, we run Cromwell, as I said, and we're interacting with Google. Google Genomics runs what's called a pipelines API. And that, in turn, is spinning up servers on Google Cloud's compute engine and accessing Google storage on the researcher's behalf. GATK is front and center in Terra. So there are some featured workspaces, featured workflows, data, public data sets, things like that, that are very easy to interact with. This is an example of batch analysis. And Terra also offers the concept of interactive analysis, which is essentially Jupyter notebooks. They have, I think, the ability to run arbitrary Python and R commands within there. I'm not as familiar with this aspect of it. I work on the batch analysis side, but it's very flexible. You have a lot of options in Terra of your sources of data, the workflows you run, and how you interact with your data. I think that's it. Do we have any questions? Has anyone tried Terra yet? Not yet. Okay, that's today. That's this week. Okay, thanks. Of CWL pipelines? Yeah, so they're not currently supported on Terra. It's still, it's supported in Cromwell itself. So if you're running your own Cromwell or developing locally, you can use CWL. I'm not sure what the plans are for Terra with regards.
Do you mean just in general?
In general, I find this CWL, WDL, similar. And then
Yeah.
the need of developing again WDL or the existing CWL or some data.
Yeah, so the main thing, so CWL and WDL, and WDL we call WDL just because it's easier to pronounce. I don't know that CWL has an easy, maybe Cowell? I don't know. Simon Cowell? Anyway, they're the two main languages that are considered standards by the Genomics Alliance, Global Alliance for Genomics Health, G4GH. And so the goal there is to provide interoperable languages, kind of interoperability and portability through some of these standards. The main difference between those two, I would say, from my perspective as a user advocate, a researcher advocate, is that I find WDL much easier to work with for people who don't have computing background. So CWL is in some ways more powerful and has like technical features that are possibly more advanced, I want to say, but it is a lot more technically complicated to use if you don't have a stronger computing background. So if you haven't ever done any scripting or that kind of work, programming, CWL tends to be harder to start with, whereas WDL is meant to be much more accessible and to kind of, I don't want to say beginners necessarily, because many of you will probably never need to have scripting, to do scripting at a very advanced level. I mean, depending on what you want to do. Many of you may consume other people's pipelines, but not necessarily write your own. You know, both cases kind of apply. For a typical GATK workshop audience, I don't mean to presume anything, but in many cases, you may not want to ever do any really advanced programming or scripting. And so WDL is a language that gives you what you need, and that is accessible enough for people who don't intend to learn programming, whereas CWL is a bit harder for that crowd, I think. And so that's the biggest difference, if that makes sense. People who are more advanced sometimes say that they find WDL too constraining, that they don't have enough flexibility with that language. For sure. Go ahead.
I was wondering, out of curiosity, what were the issues with the 14 other?
That's a great question. I can't say that I was there for that evaluation. I'm not sure what they found lacking in others, but you know,
I can speak to a little bit of it. Yeah. I was there in the periphery, and it's mainly at the time we weren't happy with the options, the existing options, mainly in terms of flexibility of backend, like the ability to connect to various different types of platforms. We wanted a language that would be a system that would be super portable, because at the time we were doing most of our processing on premises on a local cluster, but we knew that we wanted to move to cloud. And in the early days, we didn't even know for sure which cloud we would use. And so we needed a system that was going to give us maximal flexibility. And I say that from the perspective not just of GATK, but like the data sciences platform, which does a lot more than that, just GATK. So that was something that we needed for the Broad's production needs. Then in addition to that, there was kind of the accessibility of the language. Because we wanted people who are computational biologists to be able to work with that language and not have to think a lot about the programming side of things, but just be able to use something. It's very similar to like a bash scripting model. And so the interoperability, portability, the accessibility, both for our own computational biologists and also for our audience. Because at that time we already had tens of thousands of people using GATK. We had previously tried distributing GATK pipelines that were written in Scala, which is related to Java, and people had a ton of difficulty with that. It was really hard. And so we wanted something that would be easy to provide and maintain, and even if you don't end up using our pipelines as written, it's a lot easier to read and understand what's going on in the pipeline as opposed to some other languages. So that's kind of a roundup of the main factors that were involved.
So specifically, we need to change around snake a bit in the wheel. So have you compared it?
We're not forcing you to change. If you prefer to keep going with SnakeMake, that's a valid life choice. We're not judgmental. But if you do want to, if you are interested in adopting WDL, we can certainly help you do that. Is that the question? I feel like that's not quite your question.
It looks like the WDL is very good for the cloud computing, right?
So it's really not, I would say it's really not specific to cloud computing. So it can do like traditional on-prem execution just as well. And there's like multiple classic job schedulers that are supported, like SG, I think LSF, Slurm.
Yep.
Like all the main popular job schedulers are supported. But it's true that WDL, compared to, and I've never used SnakeMake myself, so correct me if I say something wrong, but I don't know that it has that support for cloud backends built in. Whereas Cromwell has, like the most advanced one really is the Google backend, because that's the one we use, and we also got Google to devote engineers to actually building the pipelines API. They pretty much built that for us, and they keep improving it, kind of in response to our needs. But Amazon has been developing Cromwell backends, and the AWS backend is getting there.
Yep.
Alibaba in China has also developed a backend for Cromwell, and we're trying to use our position in the ecosystem to encourage other cloud vendors to develop similar components for them to stay competitive in the genomics domain, and at the same time to offer more options. Because even though we are functioning almost entirely on Google at this point, what we care about is making sure that everybody in the research community can use the tools effectively. And we don't really care about any particular commercial vendor. If you're married to AWS because of other reasons, we think you should be able to work to run Cromwell just as well on there. And so there's some things that have been evolving. For example, running the whole genome pipeline on Google. When we originally started about 3 years ago, it cost us $45 per whole genome to go from unmapped reads to a GVCF or final VCF. Today, it costs us $5 to do the same thing. And we're working on a version of the pipeline that costs $3 per sample. And that huge drop in the cost has been driven very much by Google engineers helping us take advantage of all the little tips and tricks and features of their platform. The next step is to make sure that other vendors like AWS help us do something matching so that people can see which platform is more competitive. So we're trying to encourage a little bit of healthy competition there to make sure that ultimately that benefits the research community, and we can all just get more research out of our funding dollars, if that makes sense.
Easy to fine-tune different backends.
I think that's more a question for Dan.
I think easy is subjective. You can do it. We have a pretty extensive documentation on backends. We have examples of backends configurations. I would encourage you to go to GitHub and check out the code, because the documentation is there and it's nice, but ultimately it's pointing to the code, and there's like a JSON style configuration file that will be what you'll be working with. But there's Cromwell documentation. I'd start there.
And we can certainly help you, point you to the relevant information to. Yeah, it's definitely.
That's what the documentation comes in handy, because it points you specifically to what you should focus on to run it on whatever backend you're looking at.
Though I will say, operating Cromwell is not really something we expect an end user, like a researcher, to do. Honestly, typically it's either your IT support person or development operations person is going to be supporting that. But if you don't have that kind of resource, that's where something like Terra comes in, because then you can actually, and it's not the only platform, but it is one of those platforms where you can actually focus on just running your pipelines and not worry about operating a server, because that tends to be a bit much.
Yeah.
Yeah, exactly. So Terra works on Google Cloud, and it's basically a layer that gives you access to the same stuff we use in production, but it's just kind of meant to be a user-friendly layer that gives you access to Google Cloud's power without having to think about what kind of machines and how to manage them and all that stuff, because honestly, who has the time? Cloud is really great in the concept, but then when you look at the management tools the vendor gives you, it's technically too complex for most of us, and I include myself in that. I wouldn't want to have to manage resources directly through their interface, but that's why we built this thing specifically as an interface to allow people to, the taglines, focus on your science, so that you can actually run your pipelines and manage your data and do your analysis, but not have to deal with that sort of thing. And I know different people at different institutions may already have access to something that does something similar, but if you don't, here you go. That's my pitch. Thanks. Okay, awesome. Bhanu, do you know how we're doing on time and when the coffee break happens? Remind me. Oh, okay. So how about we break for coffee, and then what we'll do? Hang on. Let me finish. Wow, there's definitely an appetite for coffee. Talking about infrastructure will make that happen sometimes. Sorry, Dan. No offense. Yes, so we'll break for coffee, and after that we'll go through the case study where we show you how to, in practical terms, how do you actually, if you've never done that, how do you design an end-to-end analysis? What are the pieces and the different types of work that you need to do on the way to getting the results you're going to publish in a paper? But for now, let's do coffee and come back in half an hour, I guess. What time? Yeah, let's come back at 2:45 with energy and motivation for the last piece of today. Yeah.